Hey everyone, welcome back to my channel EduVibe. In today's lesson, we are doing the next topic of the atomic physics, which is the radioactive decay. We're doing all the theory part of this radioactive decay part today, and we're doing some types of this in the next lesson. And yeah, let's start with the theory part first. So, radioactive decay is the process by which an unstable atomic nucleus loses energy by emitting the radiations. So what is that? So it's a process when the unstable atomic nucleus loses the energy and they're emitting the radiations. It happens naturally certain atoms whose nuclei is not very stable. So this happens because of some atoms have not very stable nuclei. Atoms are made of the protons and nucleus in the nucleus, as we discussed. If the balance between them isn't right, the nucleus becomes unstable. To reach a more stable state, it releases the energy of the particle that is called the radioactive decay. So that's the whole process they do. Protons and nucleus are made of, and the balance between isn't when is not right, nucleus becomes unstable, and for stable that state, they releases the energy of the particles by emitting the radiations, and that process and that thing is called the radioactive decay. There are the three types of that. We have alpha decay, we have a beta decay. Beta decay has the two types, which is beta positive and we have a beta negative. And last we have a gamma decay. We discuss all these decays separately in the theory context for now, and we discuss some other things in the next lesson. Alpha particles are the helium 4 nuclei. So helium 4 without the electrons. They don't have the electrons in that, they have only nuclei. So the alpha particles that have a very lowest penetration ability. They are blocked by the skin, a sheet of paper, or the few centimeters of the air. So this is very like this block the skin. This will not very much harmful, but somewhat is very harmful. Alpha particle dangerous when swallowed, since they are ionize the cells of the destructive trait. They possibly cause the cancer of the internal surface cells. So that's all the side effects of the alpha particles. Alpha particles are not good. We will also doing the beta particle gamma radiations, which are not good. So this all three are very not good, but we have to going from very high to the very low to the high one, which is alpha is very low thing. That is not very dangerous. When they swallowed, then it's dangerous because will ionize the cell or digestive trait. Next, we have a beta particles. Beta particles have the two types, beta positive and the beta negative. Beta particles have very high energy electrons. In the case of beta negative, they are very high. Or the high energy protons, which is the beta positive. More on this we later. So this is the anti-atomic particle. We discussed that thing in later on lessons. They have a greater penetration ability than the alpha particles. So this thing is very moderate thing. Not very low, not very high. So beta particles very in moderate state, and they have a greater penetration ability than the alpha particles. Which while the alpha particle can penetrate the skin, they are blocked by many sheets of paper. This can penetrate by the few sheets of paper or very few centimeters of air, but this can be penetrated by the uh, many sheets of paper, wood, or a few milliliters of aluminium or the salvometers of the air. What are side effects? They are dangerous to outside skin cells. So at the outside skin cells, this is very harmful. They're very dangerous. So that is the UV radiations. So UV radiation is another beta particles. And are also dangerous when swallowed. However, they are the less dangerous than alpha particles as they ionize less frequently. Somewhat they are very less dangerous than alpha particle because they ionize less frequently. Not very less, they very frequently. So that's why this is says that these have a greater penetration ability, but not very dangerous as the alpha particle. Because only one reason, which is the ionization frequently. Okay. Next thing, the last we have a gamma particles. We have a gamma radiations or gamma particles, which is noted by this. And the gamma radiations are the consist of very high frequency and they have very low wavelength, very high photons, and have a very greatest penetration ability out of all the types of radiations. So gamma radiation is very dangerous. So this is the dangerous, and this is very dangerous too. So gamma radiation can pass right through the body and they can be blocked by several centimeters of the lead, couple of the meters of the concrete, or the several kilometers of the air. So again, this is very much very harmful for our body too. So it can penetrate throughout the entire human body. They don't ionize any cells, including inside bones. However, they tend to pass through the body without ionize any cells, so they are only dangerous at a higher intensities and for long time periods. So very dangerous, great test penetration ability, and high frequency, and they have a low wavelength. So that's the thing you have to do, and their entire human body can be dangerous for that. There's a summary for that. So typical penetration we want you, so you can take the screenshot of this because this is very important. This is very nice thing. So you have a high ionization, moderate, and the low. Alpha and the beta particles are very low dangerous, but the gamma are very high dangerous to us. So that's the thing. You can take the screenshot from here. And the one thing more in this, one or two things more, they indicate that they can use electric and magnetic fields to separate the three types of radiations. This thing is very useful because in magnetic fields, so if the source is over there, the particle goes like this. The gamma is not. This is gamma radiation, the undeflected, and they look straight. And the beta negative go with the LHR, which is the left hand rule. It goes down towards like this. If the electric fields, the radiation again goes straight, which is undeflected, a particle goes down, and the beta negative goes up. They reverse these things. So the magnetic fields and electric fields are most like separated by the three types, separate to all the three types of radiations or the particles, you can say. Radiation is something that we have taught to fear, and however, we are constantly being bombarded by the low amounts of background radiation formed from the sun. So sun is the type of the background radiation. They like releases the radiations which are very low amounts, which can harmful our body. So these are the cosmetic rays, radioactive material underground, essential from a diverse variety of the sources. However, this radiation is also have a very low intensity and is unlikely to lasting damage to our body. The damage that is done can simply be repaired by our body. So this small damage can be repaired by our body. But if there's a big damage to us, so this can be like a very harmful, very dangerous to us, somewhat we can say. So the radiations can be very harmful. So for this, we have to take some precautions of that how can you that very control that thing in your body. So this is very important. If you are opposed to a huge, like very huge amount of time, we will stay over that there is a radio decay. Things can be happen. Short term of dose of radiations will result in a massive ionization causing various sickness and the likely death. So from here you can say this is very dangerous. If you can see that this type of sign, radiation area, so which means that area is have some radiation, which has some radioactive material is going on that area. So you have to stay away from that areas because they are very harmful radiations they can release. The moderate still low of radiation which can form leads to the cancer. That's why the cancer is cancer is always like the main symptom of cancer is the radioactive decay, radioactive material radiations. When working with radioactive material, safety can be improved. Three ways. So some people are working in the factories where the radioactive material can be used. So decrease the exposure time, increase the distance between yourself and radioactive material, increase the shielding. You have to do some protection. You have to do some shielding in your face, your hands, your body parts. That will not you have that contact with radioactive material. So these three ways you have to follow. So radioactive somewhat is very dangerous, somewhat is very useful to us in the very useful manners. So that's all you have to do with that. There is some theory part and you get some questions sometimes. 2 to 3 questions, 2 questions maths you can get from this. And the main thing you have from the magnet fields and electric fields of this part. So you have to know so this theory. We move on to this thing again in the next lesson. We discuss some the regression type thing in that. So that's all for this next lesson. And so this is all for this lesson for reader. We continue this lesson in the next lesson. So let me say where do I learn smart not harder. Please like, share, and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Be listening at it with EduVibe.